Before we dive into the first pipeable operator lesson, I want to stop to take a quick look at marble diagrams. If you have read any articles on ArcGIS or have visited the official documentation, you've probably noticed these types of diagrams scattered throughout, generally used to explain operator behavior. Each diagram features a line or several on top, followed by a box with the function signature, and finally a line below. But what exactly does each of these items mean? Well, let's break it down. The first line represents an input observable, with the arrow on the end representing the passage of time from left to right. This could really be an observable emitting on an interval, a single value, it really doesn't matter. For the sake of operator marble diagrams, the details of the input observable aren't important, only the values that it emits, which will be featured on this timeline. Next, we have a box underneath. This contains the name of the operator being applied to the input observable, as well as any configuration options passed to that operator. For the sake of example, we will use the map operator since it's the first operator we will be looking at in the next lesson. If you recall from the previous lesson, operators take a source observable as input and return an observable as output. The third line on the marble diagram represents this output observable after the operator is applied. So, for instance, if we called pipe on an input observable supplying the map operator, the output is the observable returned from map. If we were to convert this diagram to code real quick, you can see how it relates. So now we have an input observable, an operator, and an output observable represented, but what we don't have yet is what gives these sorts of diagrams their name, the marbles. In the case of marble diagrams, the marbles are simply circles that represent values emitted by the observable. This lets us better visualize the result of applying an operator to an observable by seeing how values emitted from the source compare to values emitted by the output observable with the operator applied. For instance, our input observable may emit the value 1 represented by this circle or marble. This value is received by our output observable, which takes the value, multiplies it by 10, and emits the result. The same happens when the value 2 is emitted, and every value emitted by the source observable. Once we understand all of these pieces, you can reason about the behavior of an operator at a glance by simply comparing the input and output. In this case, applying map to an observable returns an observable to values transformed by the projection function we supplied. Now, there are also a couple of other indicators you may see on a marble diagram from time to time. The first is for completion. For example, we know from a previous lesson that the of creation operator emits the values you provide and then completes. When you look at that on a marble diagram, this completion notification is represented by a solid vertical line. Another element you may see is an X, which indicates an error notification. For instance, if the input observable in this example emitted a string, this can't be multiplied by 10, so an error would occur on the output observable. While marble diagrams can be confusing at first, once you understand the basics, they can be a great way to visualize the behavior of most operators. In the masterclass course, we will even see how you can use text representations of these diagrams to write unit tests. Moving forward, with each pipeable operator lesson, we will start with an animated marble diagram to break the ice before diving into the nitty-gritty details and use cases. Let's get started with the map operator.